Hi friends, you are welcome back to another interesting question. We are to determine the area of this cyclic quadrilateral. We have here a right angle. This point O is the center of the cycle. We have two other angles with sides 45 degrees and A. From here, the length of side ST is 1 kilometers. So how can we solve this? How can we calculate the area of the cyclic quadrilateral? It is very simple. Starting from these two angles, obviously they are subtended by the same arc to the circumference of the cycle, and we know the angle subtended by an arc to any point on the circumference of its cycle is the same. So since this is 45 degrees, this must also be 45 degrees in size. Now this chord PV passes through point O, which is the center of the cycle. That makes it a diameter of the cycle. It subtends this angle PSV to the circumference as well. And we know the angle subtended by a diameter to the circumference of its cycle is an angle of a semicircle, which is right. Let's take a look at this triangle. It is a right angle triangle and it has an angle 45 degrees. Based on the rule that the summation of angles in a triangle is 180 degrees, this angle must be 180 degrees minus 90 degrees minus 45 degrees, which is 45 degrees. We have two angles of the right triangle to be congruent. That makes it an isosceles right angle triangle. The perpendicular sides are going to be equal, which are this and this. Let's assume their lengths to be x each. Come here, this line PQ, extend it here to meet another line from this point S at right angle. This angle here is an exterior angle of this cyclic quadrilateral. From the cycle theory, there is a rule that the exterior angle of a cyclic quadrilateral is equal to the opposite interior angle, which is this here. So if we let this be A, this must also be A. Call this point A. Look at this triangle. It is a right angle triangle and it has an angle A. Same is for this triangle. It is also a right angle triangle and it also has an angle A. That makes the two triangles similar, but we observe that this hypotenuse is congruent with this. So that makes the two triangles congruent triangles. Therefore, this side facing angle A must be congruent with this side also facing angle A. The length of side ST is 1 kilometers. Therefore, this must also be 1 kilometers. We write it out. The triangle APS equal to triangle STV. Here, this angle is also subtended by this diameter, hence it is a right angle. Let's take a look at this quadrilateral. We observe at least 3 right angles in it and 2 adjacent congruent sides. That is only possible in a square. Hence, it is a square-shaped quadrilateral. So therefore, this side and this side are also 1 kilometers in length. If you look at this quadrilateral in question, it is made up of this triangle STV and this quadrilateral PQST. So we say area of cyclic quadrilateral equal to area of PQST plus area of triangle STV. We replace STV with APS. From this square, if we subtract the area of this triangle, we'll be left with the area of this quadrilateral. So we say area of the quadrilateral PQST equal to area of squared minus area of triangle APS. Replace this with area of squared minus area of triangle APS minus area of triangle APS plus area of triangle APS is 0. The formula for calculating the area of a square is the square of the length of one of its sides, and the length of the side here is 1 kilometers. So area of squared equal to 1 kilometers all squared, which is 1 squared kilometer. So area of cyclic quadrilateral equal to 1 square kilometers. Thank you for watching. Please like, share and subscribe, and also turn on notifications. Thank you.